activity, and we have to make here the type alias for camera bitmap output, as we are working on the bitmap images. As the machine learning for the image processing, we have to convert the image into the matrix, and that is possible by only the bitmap. So that's why we are using bitmap here. Okay, then can see that I am making some space as I have to create many variables. The first variable is private var preview, and it is of type preview from camera X library, and make it show null. And then the image analyzer from the image analysis library of Android X camera. That library we have implemented in the Gradle file. Again, one more variable here is of camera provider, process camera provider from the library process camera provider, sure null, and then the lens fetching. This variable will be used for turning the camera from front to rear. So it is of int type, and then camera selector dot lens facing front is a default, and then again this is camera, and now make sure null. After this variable, we will be making the last late init variable, and here it is camera executor, and it is being used for executing the service for camera from Android device. Okay, so we are almost done with the variables that we have to declare. Now is the time to come into the onCreate method, and within this method we have to call some functions that we are going to implement, and one of them is setup ml, the second one is setup camera thread, and the third one is setup camera controllers. Afterwards, we have to also take up the runtime permission for using the device camera. So we have to make sure with the permissions granted with this if condition. If all permissions are not granted, then we have to call for the require camera permission method that will be used for getting a dialog box for the permission of camera. And else if it is provided, then we have to go to for setting up the camera for detecting the face mask. So the function for that is called within this else part. It is setup camera, and now we have to make these functions that we have declared here. So first of all, which function that we are going to implement from there is setup camera thread, the second one. Okay, so within this function we just have to get the service by executor dot single thread executing for the camera service of the Android device. So camera executor equals to executor dot new single executor thread executor. Okay, the second function is camera controller, setup camera controller, and within this we have to use that set that button for lens facing. So we have to make another function within this function, and this function is set lens button icon. So as we are changing the button icons also, as if you have clicked on that front icon, then the another icon will appear for changing it to rear one, and vice versa. That's why this function is pretty useful here. So now app compat resources dot get drawable, and within this getting the application context and checking for the if lens facing is equals to camera selector dot lens facing front, then make it to that r dot drawable dot ic rear one. Okay, and else just do the opposite of it, the front one, r dot drawable ic camera rear. Okay, so now we have to call this function set lens button icon. Within that setup camera controller. So let me come out of this inner function, and now I'm in the outer function and calling this inner function. Okay, so now we have to set the set on click listener for the button camera lens facing. You know how the camera facing is changed from rear to front. We have to do it from this set on click listener. So we just have to change the value for that camera selector. So here we are checking. First of all, we have to check if the camera selector dot lens facing is front and equals to our lens facing variable. Then we just have to change it to lens facing back, and else in the else part we have to just make opposite of this, that is camera selector dot lens facing front. Then we have to again call the function called set lens button icon here. Okay, so now we have to also create one more function here, setup camera use case. Okay, so we have to call this also. Don't worry about the error, we are going to create this function also. Okay, so now we have to write a try block here. If the device camera is disabled, then what will happen? So we have to get up from that exception using this try catch. Okay, if camera information unavailable exception. That's why if it is enabled, then we are just checking for has camera back camera and has front camera. Otherwise we will be making the catch exception camera info unavailable exception. Okay, if the device camera is damaged or something buggy within the camera, then the exception will handle that situation. Okay, don't worry about that error of has back camera and has front camera. We are going to implement a class companion object we are going to do for it. Okay, so now this is complete, and here we have to implement one more method, and that is require camera permission. So just create it, and now we are just checking for the permission. Then use that activity compat dot request permission, pass the context here this, and then required permission and request code permission. Also this will show the error, as these all variables will be the part of that companion object within this main activity class. Okay, so don't worry about this red line or the red text. Okay, so this function is done. So now we have to implement another function, and that function will be, we have to search for it, otherwise we have to make it by ourselves. Okay, so we have to make it by ourselves here. So let's make it, and it will be known as require camera. Require camera permission is done. Now it is granted camera permission. Okay, granted camera permission and having the parameter as the request code of integer type. And then finally within this function we have to just check with the request codes and the request code permissions, and if all the permissions are granted and everything is okay, then we are just have to call that setup camera. Okay, otherwise we have to show the toast message that permissions are not granted by the user. Okay, so if the permissions are given, all permissions are granted, then we are going to set up the camera as we are going to do within this if condition. So let me do it here, set up camera. Otherwise, if it is not the case, then we have to show a toast message here, toast.makeText, then passing the context this, and then a message will be appear here, permission not granted. Okay, and now the toast.length short, and finally we are going to show this. Okay, so you can choose the length as per your choice. I've chosen the long one. Okay, then we have to call the finish function here. So I think we have called up the finish function in the wrong space. We have to call this finish function just after that toast message. So here, okay, so first let me adjust these curly braces, and for now this function is completed, and now we have to implement another function, and that function will be set up camera use cases. So here it is, and within this we have to choose the lens facing selector, and camera preview will be appear here, and image analysis will also be the part of this method, and unwinding, binding, all these things will be the part of this setup camera use case. So very crucial function. So first of all, the lens facing selector, so making a variable, then camera selector dot builder dot required lens facing, getting the lens facing, and finally build that camera selector. Okay, and now what we have to do is we have to make the preview for it. So let me make here builder is a function, so just write that parenthesis. Okay, so now the camera preview, and within the camera preview we are going to use that matrix display metric, and then display metric dot also here preview underscore view dot display get real metrics, and pass the iterator within it. Okay, as we are working on a real time with the camera, that's why we are doing the displaying metrics. And then the rotation, so what will rotation get, preview view, then display dot rotation, afterwards the screen aspect ratio. So this will also call this function called aspect ratio, and within that you have to pass the metric dot width pixels and metrics dot height pixels, and then preview equals to preview dot builder. You have to build that preview with respect to that target aspect ratio and target rotation. So first of all, the target aspect ratio, pass the screen aspect ratio within it, and the second one is target rotation, pass the rotation within this, and finally you just have to build this. Okay, So for now, the image analysis part starts from here. Very important. So image analysis dot builder, and then you have to set target aspect ratio and target rotation, and you have to build this as just same as the preview in the previous lines. Okay, so just build it, then called also, and then getting that iterator set analyzer from the camera executor service to the bitmap output analysis, passing the base context of the application, and it is application context. So first of all, write it correctly, camera executor, and then bitmap output analysis, then finally application context, and afterwards you just have to open this, and then bitmap is such that set, so lambda function here, set up ml output and pass the bitmap within it. Okay, and finally you have to unbind the last binding of the camera, so just you have to write one line for it. So what that one line here, we have to make some space so that you can see the screen perfectly. Here it is, camera provider dot unbind all, just for unbinding the last binding part for the camera service. And then now the binding this time, and it should be in the try catch. So get bind to life cycle and pass the camera selector, preview and image analyzer within it. And now the preview for setting up the surface provider, pass the preview dot create surface provider here, and afterwards you have to make a catch block here. That catch block will get the exception and a log will be there, like use case binding failure appears here. So we are getting a log for it within this catch part. So just use case binding failure. Okay, so it is binding finally failure, and then you have to also print this exception here, exe. Okay, so this is also done. Now we have to implement one more function, and what that function will be, it is setup camera. So this is also the one of the important function for setting up the camera from the camera provider future, listeners and lens facing. And then first of all we are getting that camera provider future, and then listenable future, then process camera provider. Afterwards you have to get is the instance for the process camera provider by passing the context. And now the camera provider future dot add listener, and as we are working on the multiple threads, we have to use the runnable here. So we have to use runnable within this. First let me change it to the small case. Okay, so now you have to write runnable, and within the runnable you have to get the camera provider feature dot get, and with this get what you are getting is lens facing, and then there is the when condition appears. So when has front camera is camera selector dot lens facing front, and then that of camera back camera, then it is lens facing back. Okay, otherwise it will throw a illegal state exception. like no cameras are available on this device. Either maybe the device is having some hardware issues. So just print that exception, throw it. Okay, like no camera found on this device, no camera available. And then you have to call some function like setup camera controller and setup camera use case here. So first of all, let me check the parentheses and curly braces so that I can make correct statements here. Okay, so here I'm checking for it, as I'm worried about that there should be no such errors related to this. Okay, so first of all, let me do it rightly. So here we have to do it, call the functions setup camera controller, and the second one setup camera use case. Afterwards you have to write context compat.get main executor by passing the context this. So write it here, context compat.get main executor, pass this. Okay, now we have to make few more functions, and that function is all permissions granted, and it is returning the boolean as we have used it within this if condition earlier part. So it is a getter, so just get, then just returning these things, like only one line it is containing, like return required permission all. Then we are getting that iterator. What does it contains? Like context compat dot check self permission base context comma iterator, and then if it is equals to the package manager dot permission granted, if it is equals to the package manager, so write equals package manager dot permission granted. Okay, done. Afterwards we have to make few more functions here, and now some functions that are being overridden here. So the function, what will it get? Like let me first of all make this has camera first of all. Okay, so what does it given, like has camera, it is also returning that boolean. So I'm doing the first, the functions that are returning something from getter. So one of them is has back camera, and the second one is them has front camera. So I have told you that this will be a part of companion object, but this is not the case, as these are the boolean functions that are returning either true or false things. So the permission ones are the part of that companion object. We will be seeing them a few moments later. So now default front camera. Okay, done. Afterwards these functions are done. Now we have to see which functions we have to write here. So let me go for the override, but you don't have to write it, just write the name of the function. It will appear by default in the suggestion part. So just like that, on request permission result. So as you can see that on request permission result is getting 3 parameters, and you just have to write one function here, granted camera permission, and pass that request code within the parameter of that function. After that you have to make on configuration changed overridden function, then one line setup camera controller. Okay, so this is function is completed. And now the functions like we have to see, but first of all let me make a space. Actually functions are return code lines. So this is aspect ratio, and it is getting in the parameters width, height. Also it will return something, that's why int. And then we are just going for that preview ratio and getting maximum of width and height, converting it to double, and then we are dividing it by minimum width and height to get the aspect ratio. Okay, then we will also check within the if condition in the next line for the absolute value of preview ratio minus ratio 4/3 value should be less than equals to absolute preview ratio minus 16/9. So first of all 4/3 value, and the second one is it should be less than equals to absolute preview ratio minus ratio 16/9 value. Okay, then you just have to return that 4/3, otherwise you have to return 16/9. So just return 4/3 here, and in the later case just have to return the 16/9. Okay, the second one done. This function is completed. Now the crucial functions are going to be like first of all you have to make some late init variable face mask detection. Face mask detection, it is being referred for that tflight file. Okay, and it will be appointed by using that TensorFlow libraries. Okay, as you can see that there are lots of errors, but don't worry about them. Let me see, this function is left out, so implement this here. So you just have to write options and getting the option from the model, and model is a part of that TensorFlow, as we are working on the machine learning model that is compatible with the Android device. That's why its format is tflight, not h5 as that format for PCs or computers. Okay, so builder.set device, then model.device.gpu, and then setting the number of threads by 5 and getting it to build, setting the number of threads as 5 here, and finally we are building it. Afterwards one more line, face mask detection equals to face mask detection, and getting the instance for it by application context and passing the options within this. So first of all context and then options. This function is completed, but it is showing errors right now, so we have to debug all this. I think this is because of, but first of all let me implement this setup ML output. I think the error is because of the libraries are not downloaded successfully because of slower internet connection. Don't worry, I will do it after completing this class main activity. Okay, so within this setup ML output and getting the bitmap within the parameter, we have to work on the TensorFlow image and the output result. Here we have to get the probabilities as per the category listed. Okay, so First of all, it is tensor image dot from bitmap, pass the bitmap, and then the result face mask detection dot outputs equals to, you have to process the face mask detection, the tensor image, and finally get that output within the list of categories. Okay, it is not locally dot category, so remove this local and then just try to see if there are more options available, but it is not ulocal also, so leave it as it is. Okay, then finally you have to get that result dot probability as a category list. Then you have to apply descending sort, as the highest probability result will be taken into the accounts. That's why we are using the sorting by descending and getting the first value, as it is having the highest numeric value. That's why we are getting it into res dot score. Okay, it is the score, like how much score or the possibilities that the user is wearing the mask or not. Okay, so now the life cycle scope will be followed up, and launching the dispatcher for main, and then the coroutine scope will be there. So first of all, the dispatcher dot main, and within this just have to output dot first or null, and then the let, and afterwards you have to work on that categories, and by category tb output dot text equals to category dot label, as it will be showing up that if the user is not wearing the mask, then there will be a text of without mask, without underscore mask, or if there is mask, then with mask text is being labeled on the screen. Okay, so you can see that context compat dot get color, as we have to also work on that color. We are choosy on a red and green color right now. Green color if the user is wearing mask, and for red color is being used for if the user is not wearing any kind of mask. Okay, so first label it without mask, and it's will be in the red color, otherwise the green color. Okay, so now we have to overlay also, and that overlay dot background get drawable, and we have to overlay that borders that we have made out customly. Okay, and that borders will also work as per the labels. If the label is with mask, then the green border will appear, and if the label is without mask, then the red border will appear. So for the without mask, the red one, r dot drawable dot red border. In the else part, r dot border, r dot drawable dot green border. Okay, now the output part for PB output for the progress, and what that progress will there, actually it will be having that progress, like what are the chances right now, and it is like app competitor source dot get color state list, as it will also work as per the colors. Okay, if the progress is 0, then the red color, and if the progress is more than 60, 70, 80 and up to 100%, then the color will be green for the progress bar that will be appear just above that text view. Okay, so now else part, r dot color dot green, as you can see that now output dot progress, and category score multiply by 100 to int, as we are just getting the percentage of this score by multiplying by 100 and getting the value to integer. Okay, so now what is left out, but it is progress. Okay, corrected. And now let me remove the extra space first of all and make some space for the companion object. Right now the companion object for the values which are being constant within this application, like tag, request, code permissions, required permission, ratio 4:3 values, ratio 16:9 values, like that. So the first one is constant value tag, and that tag will be getting the name as face underscore mask underscore detection. Afterwards, the request code permission is there, and it is also having that x value 0x98, and then the required permission, it is actually the array of strings, and getting it from the manifest dot permission dot camera. Okay, again the ratio 4:3 values, and then ratio 16:9 values, make it to double here. So like that, first one is 4:3 values, double, like 4.0 will be divided by 3.0, and then there will be another one for that 16:9 value, and it will also be similar, like 16.0 will be divisible by 9.0. Okay, so this companion object is completed, but let me see what is left out or what next I'm gonna do within this project. Okay, so now what is being left out, let me check for that. The braces, actually the curly braces are important part of this. Now let me check. You can see that the ratio is being defined within that companion, but it is showing that reddish text. So let me get that companion below this function so that the error can be removed. So where it is, let me search for it. Here it is, the companion object. You can see that 4:3 values. So what reason it is, just cut this and just have to paste below that function here. So just you can paste it here. As you can see that error is removed from the above part. Okay, so for now we have to make two more functions, and for that the one function is like what that one function will be, but it will be relating to that face mask detection. Let me remove this and let me check setup ML is being done, and it will be here only. Okay, so here you can see that. Good work. And now we have to make another function, and it's not the function, it's actually the class we have to make within this class, and this class will be called bitmap output analysis. It will be analyzing the output based on that rotation matrix, bitmap buffer, and that converter kind of things will be called up from here. So it will just having context as its data member and camera bitmap output listener. Okay, and now the image analysis dot analyzer will work. Okay, so how does the analyzer work? Private ball YUB to RGB converter equals to YUB RGB converter, pass the context to it, and then late init variable bitmap buffer of type bitmap, and the another one late init variable called rotation matrix. It is of type matrix only, and then you have to suppress the lint for unsafe experimental usage error. So first of all, do this matrix, and now you have to suppress the lint for unsafe experimental usage error. So I'm just writing here. What is not coming in that suggestion box? Actually, I'm writing the wrong spelling. Okay, so now it is correct, and pass a string within it, a value like unsafe experimental usage error. Okay, afterwards you have to make another function called image proxy. So this function will be responsible for passing the image to the image analyzer and creating the bitmap in the correct orientation. So first of all, let's go for that image within this function, and it will be returning that bitmap. Okay, so make variable image and should be equals to this dot image. Make sure about null liability, and then the if condition, if the bitmap buffer is not initialized. Okay, bitmap buffer dot is initialized, and then within this you just have to call rotation matrix equals to matrix, and then rotation matrix dot post rotate, and this dot image info dot rotation degree dot to float, and then this dot width you have to pass for that bitmap creation, as you have to create a bitmap here for this dot width as per the height and width of the bitmap. So this dot width and this dot height, and then the configuration for that bitmap is ARGB 8888. Okay, so it is done. Now you have to pass the image to the image analyzer. So just write YUB to RGB converter dot YUB to RGB and pass the image and the bitmap buffer. And now you have to create the bitmap in the correct orientation here. So here the final value for returning that bitmap dot create bitmap, and pass that bitmap buffer 0 for x and y, and bitmap buffer dot width, and then that of height, then rotation matrix. Afterwards you have to get no filter, so false for the filter. Remove this extra space, and one more function analyze here. It is the last function, and here you just have to call that image proxy dot to bitmap, check for let and then listen iterator, and then you have to close this image proxy, but first of all let, then listener for the iterator, and then you have to close this image proxy here, image proxy dot close. Okay, so now this is a function. Actually you can see that image proxy is closed, and let me remove this extra space from here. Okay, so as you can see that there are lots of errors. So first of all let me go to this and just click on synchronizing it. Okay, building and downloading the models, downloading the life cycles as I've said, and afterwards it will take some time as the internet is slower. Don't worry. Done. Okay, so now it is error free, and I'm just scrolling down, and if you have messed up at anywhere or getting still error, then please check every line in which you are getting error by my line. Make sure it is same as of mine, and there should be no error. As you can see that this class is now error free. And now just scroll down. Okay, I have put that close parenthesis. Okay, so now it is completed and everything is good. So it's the perfect time to run our project. So finally I will click on that run button and show you the live demo of this app. So this is the end of the video series. Right now it is installing and success. So now the screen appear. Give the permission for camera, and here you can see my face. It is without mask, and if I wear the mask, then it is showing the green border with text with mask, also showing the progress bar just below that text view. Okay, if I wear the mask, then it appears to be green and the progress bar is full, and if it is without mask, you can see that progress bar is also working. Also the without mask is also working. So thank you for watching this video series. Kindly subscribe our channel Techno Learning.